Good morning, everyone, and welcome to the July edition of the Wikimedia Research Showcase. Just a few words about this showcase. It is something we've been running monthly, and we put it on hold for the past 3 months due to other major outreach activities that we're involved in, but we're super happy now to resume it on a monthly basis. So from now on, you can stick around and expect something new every month. I'm very excited also to introduce this month the first results of the collaboration we started with our friends at Jigsaw. Today we're going to have one presentation on identifying and modeling abuse in online harassment discussion spaces. Ellery Wulczyn and Nithum Thain are going to present in the first slot. We're going to have some time for a quick Q&A session at the end of it. And after that, we're going to have Daisy Chen from the design research team presenting results from research on the Wikipedia portal. After this, we'll be able to have a more extensive discussion and a Q&A at the end of the session. So please stick around. As usual, we're going to have our IRC channel, Wikimedia-research on IRC. So if you have questions, please post them there and we'll relate to the audience. And without further ado, I really need them.
Everyone, thank you for being here today. As I mentioned, so my name is Ellery. I'm a member of the research team at the Wikimedia Foundation. I'll be presenting with Nithum, who is a researcher at Jigsaw. Jigsaw is a technology incubator within Google Alphabet. And we'll be presenting on our recent work on modeling and understanding personal attacks on Wikipedia.
Hi, everyone. Thanks for the introduction, Ellery. So what I thought I'd do was start by motivating the question that we're investigating. It's well known that harassment and personal attacks are an issue for the Wikimedia projects, but this was most strikingly highlighted by the 2015 harassment survey, which was conducted by the support and safety team of the WMF. And what they found was a very high level of prevalence of harassment among the Wikimedia projects. In fact, of all the people that they surveyed, all of their respondents, 38% had experienced some form of harassment on one of the projects, and 51% had witnessed the harassment of others. So harassment has a big footprint on the Wikimedia projects. And they went on to investigate the places where harassment occurs. On the next slide. And what they found was that 92% of the harassment that occurs on the projects occurs on Wikipedia itself. But other important attack vectors were the commons and off-wiki locations like Facebook and Twitter. Now, they also investigated the impact of this harassment on the projects. And what they found was that if someone was harassed, then they were 54% of people who experienced harassment expressed a decreased or greatly decreased participation in the projects, which is a profound, powerful impact on all of the Wikimedia projects. But again, because most of this harassment happens on Wikipedia, this means that this will necessarily lead to decreased contributions on the Wikipedia project. So this leads us to the goals of our research. We set ourselves 2 goals. The first was to develop a set of algorithmic tools for detecting harassment amongst the projects. But because there's so many different forms of harassment, we decided initially to focus in. And we specifically wanted to detect personal attacks as they were happening on Wikipedia. The second part of our research objectives was to use these algorithms to label large sets of data and then perform large-scale analysis that weren't previously possible to better understand the nature of personal attacks as they occur on Wikipedia. In order to achieve our goals, we undertook the project in 3 phases. In the first phase, we collected diffs from Wikipedia talk pages, cleaned them, and labeled them. In the second phase, we built machine learning models, where we trained machine learning models on the diffs that we collected earlier. And in the third phase, we use these models to label a huge set of revisions looking for attacks and trying to understand, performed a large-scale analysis of the nature of attacks on Wikipedia. And during this talk, we're going to take you through some of the details and results from each of these phases.
Okay, so yeah, the first aspect of our pipeline is sort of how do we collect, sort of our goal in the end is to have a large data set of comments that are made on top pages on Wikipedia, where each comment is labeled with the probability that the comment is a personal attack or not. And all we have to start is really sort of the revision history of English Wikipedia. So I'll walk you through how we go from the revision history to this labeled set of top page comments. Okay, so there's a couple steps involved here, so bear with me. So MediaWiki currently doesn't have the concept of a top page comment. They're really just edits to top pages. And it is the case, however, that most edits to top pages represent a user adding a comment to a top page discussion. And so what this means is that we have to generate this notion of a comment ourselves from the revision history. So let me explain what the revision history is. It's sort of it represents sort of the history of edits as a sequence of files or revisions, as they call them, and where there's a separate file corresponding to the state of an article or a page after each edit. So the first step that we have to do in order to get sort of nice, clean comments is we have to get the text that was added during an edit to a top page. And we do this by computing a diff. And Aaron Halfaker has sort of a really nice Python library called MWDiffs that allows us to do this. So what we do is we basically compute all the top page diffs throughout the history of Wikipedia. Okay, so from the diff, we sort of pull out the text that was added during the edit, and we do a bunch of cleaning. So this involves removing all the MediaWiki markup, HTML, signatures, timestamps, all these things, just to make the text sort of nice and clean and readable, especially for our human annotators. And for user talk pages, we also remove a lot of these administrative messages, where there's sort of the same message that goes out thousands and thousands of times, and we use a bunch of regexes to filter those out, and that's because it would be sort of wasted effort to label the same, virtually the same comment over and over and over again. And then the final step, once we have this sort of nice, clean comment text, is we want to give it to human labelers, and we want to sort of scale this labeling process, which we do through a crowdsourcing platform named Crowdflower.
So as Ellery said, we want to create a set of labeled data, and the purpose of this labeled data is to give our models something to learn from, right? We need to give them a set of data where we've already indicated that things were or were not personal attacks. And the approach we did to try and generate this was to use crowdsourcing. But in the process of using crowdsourcing to generate labeled data, we had to make a number of design decisions. The first of these was exactly what data are we going to label? So one option is to label a random sample of the revisions, of all revisions that happen on user and article talk pages on Wikipedia. Now the one advantage of labeling this kind of random sample is that it gives the algorithm a sense of the actual nature of conversations that happen on Wikipedia. It'll learn exactly at what rate do personal attacks happen in the wild, and what is the language that is used in a typical conversation. Or the major disadvantage of using this kind of random sample of data is that, in general, the prevalence of attacking comments is very low. So in order to get enough positive examples of attacks for our algorithm to learn from, we'd have to label hundreds and hundreds of thousands of data, and that just thousands of revisions of data, and that was just infeasible. So in order to speed up the learning of our algorithm, we turned to another data set, and this was the blocked data set, which is revisions written by users who had been blocked for personal attacks. And we particularly focused on those revisions near the block event. Now these revisions have a really high proportion of personal attacks. They're not very typical of a normal conversation on Wikipedia talk pages, but because they have such a high portion of personal attacks, they allow us to speed up the training of our algorithm. And ultimately, in order to get the best results, we used a blend of both random and blocked data. So the next design decision we had to make was around the language of the question we were going to ask our annotators. And we struggled with this a bit. There were lots of different languages and questions that we tried, but we ultimately landed on the statement that you see in front of you, which is, does this comment contain a personal attack or harassment? Please mark all that apply. The advantage of this question was twofold. First, it allowed people to separate the idea of whether or not a personal attack was occurring with to whom the personal attack was occurring, right? So they could indicate the target of the attack, whether it was the recipient of the revision or some third party. And this opened up lots of interesting avenues of research for us. But the question was still objective and compact enough that we could get a good performance from our annotators. And in particular, we could get a good level of agreement between annotators when they answered this question. Another decision we had to make was what crowdsourcing platform to use in order to crowdsource the annotation of labeled data. We settled on Crowdflower, which is a platform that allows you to pay a small amount of money to thousands of annotators around the world in order to have them effectively fill out a survey based on data that you provide. So we provided them with these revisions and asked them the question above, and they were able to give us 20,000 labeled random revisions and 50,000 labeled block revisions. And each of these revisions was labeled by 10 different annotators, so we could take the aggregate. Now, one of the advantages with this, Crowdflower offered several advantages. The first was its speed. The second was its ease of use. But one of its key advantages is that it allowed us to do some sort of quality control. We could insert test questions into our surveys where we'd already pre-specified answers. And our annotators would have to do well on these test questions in order to participate in the survey at all. Now, I don't want to leave the false impression that the data that we obtain by crowdsourcing in this way is perfect. It's not, and there are a number of challenges that we had to face. The first is that the annotators working on this data are profit-driven. So they're going to try and answer each survey question as quickly as possible. And the second is that they may have an imperfect knowledge of English. In fact, for most annotators, English is a second language. And the final sort of challenge presented by this type of crowdsourcing is that asking someone whether or not something is a personal attack is a very subjective question, ultimately. And it can differ for different groups of people what people consider to be an ultimate attack. Sorry, a personal attack. What we did, though, was mitigate each of these challenges. So in order to mitigate annotators working quickly and having an imperfect knowledge of English, we were able to use these test questions so that they had to maintain a certain level of accuracy to even participate. And this was throughout the process of annotation. To tackle the subjective nature of the task, we just had a very large number of ratings per revision. So having 10 ratings per revision is much, much higher than what you will normally see, but it allowed us to have quite a lot of confidence in the aggregated scores of our annotators.
Okay, so now that we have this wonderful labeled data set, our goal is to build what's called a classifier that can take any comment and output the probability that the comment is a personal attack. If you're not familiar with what a classifier is, I'll explain that in the next section, but you can also just think of it as a function. And so the way that we build this classifier from our annotated data set is using a conceptual framework called machine learning. So here's a very brief schematic of machine learning workflow. So we start with comments and annotations, as we've described. And then the first thing is we have to transform these sort of text comments into numerical representations, which we'll call features. And then we also have to transform these 10 human labels or annotations into a single number. And we call this a label. And then for each comment, we feed the associated features and the associated label into what's called a learning algorithm. And that learning algorithm produces a classifier. And this classifier has the ability that you give it the features that are associated with the comment, and it outputs the predicted label. Okay, so how do we go from these text comments to these numerical feature representations. To do this, we use a method called character n-grams. And so here you have an example comment. That's great. So what we do is we enumerate all the distinct, let's say, in this example, 4 letter sequences that occur in the string. So we have that, add apostrophe s, etc. So we sort of do this for every comment in the corpus. We try to find the entire set of distinct 4-letter sequences. And what we then do is we sort of map, let's say we order them, whatever, and then we map each of these sequences to a position in a fixed length list. So there's basically this long list, and there's a position in this list for every possible 4-letter sequence that exists across all comments. And then the way we represent a single comment is we create a list that initially is all 0, and then we go through the list, and for every position where the corresponding 4-letter sequence exists in the comments, we put in a 1. And so then we get this sort of long list of 0s and 1s that represents sort of what 4-letter sequences exist in this comment. And so you might think that 4-letter sequences are sort of an odd choice. In reality, we use sequences of multiple different lengths. But you might also wonder why we use characters and not words. Words just seem like to have sort of actually have meaning. It might be a better choice. And the reason is that using these character sequences are much more robust to changes in the way people write things. And that's particularly important for personal attacks, where it's pretty common to use variants of spellings of expletives and so forth. Okay, so this is how we sort of map text into these numerical feature representations that an algorithm can understand. And then to go from our pool of 10 annotations to a single numerical label, we just sort of take the average. So we just compute the average people in the pool of annotators who thought that that comment is a personal attack. Okay, so given the fact that we have now features and labels, we give them to different learning algorithms to see which one produces the best classifier. And we ended up choosing a method called logistic regression, which is one of the simpler methods, but we also experimented with various what are called deep learning architectures, and those did not show any large performance gain, although it's still an active area of research for us. Okay, so after selecting how we generate features and labels and picking a learning algorithm, we want to be able to evaluate how good the resulting classifier is, especially in comparison to human performance. The idea here is that we're going to use one group of people to predict what another group of people thinks about a comment, and then to compare the model's predictive power to the predictive power of a group of people. Okay, so here are the details on how this works. So we're going to take a large set of comments. In our case, we took 5,000 comments, and we have one group of people judge each comment, and we're going to call this group the ground truth group, depicted in yellow. And we're going to use the fraction of people in the ground truth group who said the comment is an attack as the ground truth label. And then we're going to take another distinct group of people, so they're totally separate, and we're going to have them do the same. And we're going to call this the prediction group, and they're depicted in white on the slide. And then we're going to see sort of how well the prediction group and the ground truth group agree in terms of their estimation of whether the comment is an attack across the entire corpus. And so we're going to measure and summarize the total agreement using a measure called the area under the ROC curve. And what's neat about this is we can sort of vary the size of the prediction group to see how much more agreement there is as you average the judgments of more people. And then crucially, we can swap out the prediction group with our actual model. And here the model, of course, is trained on a different data set to see how well it stacks up to a group of human annotators. Okay, so this table shows the ROC score, which is sort of our measure of agreement, with the ground truth group size fixed at 10. Right? So we're always going to have, for the ground truth labels, we're always going to have 10, sort of average the judgments of 10 people. And then in the table, you see the agreement scores as we vary the group size of the prediction group. So if you have one person trying to predict what a group of 10 people on aggregate would say, you get in the group of 0.85. As you increase sort of the group size, there's more better and better agreement, which sort of maxes out at 0.96 when you have a prediction group that is as big as the ground truth group. Okay, so now the exciting question is sort of how does our model sort of stack up in this comparison? So it turns out that the model produces results that are equivalent to pooling the judgments of 6 Crowdflower workers. So what this means is that we can run our model on every comment ever on Wikipedia, and running this model is basically free, and we would get similar results to sending sort of the entire history of comments to 6 Crowdflower workers each, and this would be sort of prohibitively expensive. But so we can run the model for free, we can compute scores over the entire history of comments, and do some really exciting analysis.
And so we coded up a little demo to give everyone an opportunity to try out our model. And so if you go to wikidetox.appspot.com, you'll find the demo. But if you, the next 2 slides just have screenshots. So when you browse if you feel free, but when you direct your browser to that website, you'll see the following sort of demo. Basically, in order to make it work, you provide the demo with a piece of text or a revision ID, and it will automatically extract the text. And then it will evaluate 2 scores. The first is the score for whether it's not an attack, and the second is the score for whether it is an attack. And you can think of each of these scores as approximately a probability, the probability that the model thinks that the piece of text is an attack. So in this example, you see this phrase, "Congratulations, I don't know whether you're aware of this fact or not, but you've shown your qualified stupidity," which is an attack. And the model correctly identifies it as an attack with a probability of 82%. And the interesting thing about this query is the model has to navigate sort of positive and negative keywords and sort of a longer couple of sentences, but still manages to navigate it successfully to identify this as an attack. In the next example, you see the thing that Ellery was talking about earlier. One of the advantages of character engrams is that it's very robust to misspellings. So if you type expletives but use symbols, random symbols, instead of the letters, as long as the structure of the sentence is still roughly that of an attack, the model will be able to do a correct classification. So here you see the model thinks that this is an attack with a probability of 69%. So again, one of the strengths of character engrams over a bad word list or using words as features is that it's robust to this kind of manipulation. In this example, another strength of the model is that it can sometimes take context into account appropriately. And again, this is an advantage over things like a bad words list. So here you see the 2 phrases, "I will punch your lights out" versus "let's drink punch." And again, the model correctly categorizes the first as an attack with a probability of 59%, and the second as not an attack with a probability of 83%. And the key word in each of these phrases is the word punch, but it's being used very differently. And so the model is able to use the context of the word to figure out that the first case is an aggressive use, and the second case is just a neutral use of the word punch. The model isn't perfect, however. So this is a phrase that will fool the model. "Your intellect is lacking." Here the model thinks this is not an attack with 90% probability, whereas we might classify it as an attack. And the reason this happens is that this phrase is not at all similar to anything the model has seen in its training corpus. I just made it up. And so because it hasn't seen anything similar to it, it hasn't had any opportunity to train on. But this is one of the weaknesses of the model, and it indicates a need to continue to train the model, to continually train the model going forward as we use it. There are other ways of fooling the model. So by combining positive keywords and mixing up characters with letters, you can, again, trick the model into thinking that this phrase is not an attack. But you see here, like, this phrase uses please and thank you and letters, and symbols instead of letters. It'll take some work. If you really want to, if people are specifically targeting the model, they will be able to fool it for a little while. But the model will continually learn as we go forward. One final way of tricking the model is to use irregular spacing, and this is definitely a weakness of one of the character engram approach we used. Because character engrams pays very, very close attention to the order of characters and spaces, if you put sort of spaces in inappropriate places, you can still fool the model. But despite this weakness, as Ellery demonstrated, the model does exceedingly well when compared to a large group of people.
Okay, so yeah, despite some of the quirks that Nithum pointed out, the model does open up sort of exciting doors for analysis. And so, as I mentioned earlier, we can run the model over sort of the complete historical data set of talk page comments and get the probability that each comment is a personal attack. And this allows us to thoroughly investigate questions surrounding the prevalence, dynamics, and the impact of personal attacks in English Wikipedia. The first sort of most basic question we could ask is, how many attacks are there? Specifically, sort of, what fraction of comments are personal attacks? The plot here shows the fraction of comments that fall above different attack probability thresholds, broken down by the user and article talk namespaces. So the takeaway points are there's a greater proportion of user talk comments that are attacks compared to article talk. Note that this is user talk through a filter for administrative messages, and that sort of at a conservative threshold of 80% certainty, roughly 1 in 400 user talk comments is judged to be a personal attack by the model. Furthermore, so there are efforts to moderate personal attacks on English Wikipedia. Specifically, there are warnings that are issued. So there's this no personal attacks template. And there are also, users can also be blocked for personal attacks. And when the user is blocked, the admin can sort of reference the policy of no personal attacks for the reason for the block. And so here we show what fraction of users who have committed at least one attack have been warned or blocked. So for users who have made attacks with 90% certainty, 25% of them have been warned, and 15% have been blocked. So this means that sort of a lot of attackers actually go unmoderated.
And this is another type of analysis we did, and I don't want to get into a lot of details about the graph, but what it's trying to capture is the relationship between how many revisions a user writes, a total, and the proportion of all of the attacks on English Wikipedia that they are responsible for. And so what this graph tries to demonstrate is that there are two very different types of attackers that, that operate on English Wikipedia. On the far left, you see attackers with a very small number of revisions, and on the right, you see attackers with a very large number of revisions. So let's focus on each of these groups. So on the left, on the next slide, you'll see that over 50% of attacks on English Wikipedia come from people that have 1, 2, 3, or 4 total revisions, right? So this means that, one, all of these revisions have to be very attacky. Like the fraction of revisions that these users write, which are attacks, is going to be very high. And this indicates that many of them might be sock puppets. But in order to tackle a large proportion of attacks on Wikipedia, something has to be done about these accounts that have a very, very small number of revisions. The second group is the group with a very large number of revisions. So if you look at users with over 700 total revisions, they contribute 17.4% of attacks. Now, most of these users have a very small attack fraction, meaning only a very small portion of the revisions they write are attacks. But the total number of attacks adds up to a non-negligible amount. And so the purpose of presenting this slide was just to say there are very much two different segments of attackers, and it's worth studying these segments separately and trying to come up with solutions to the problems they pose as separate entities. So we're very much at the early stages of our analysis, but we're continuing it as we go along, and the things that we're going to be doing in the following weeks and months are to continue improving our model using more advanced techniques, to extend our analysis to other important research questions, including ones around gender, victimization, reciprocation. And we also plan on releasing our annotated data sets so that other researchers can join us in asking these questions, and integrating our model with ORES so that extensions and tools can be built on top of it. And that's it for us. Thanks for taking time to listen, and let us know if you have any questions.
Fantastic. Thanks, everybody. Can we come back to the room? Yes, I have one question on IRC, like relay, like inviting the questions also through Chinese. I have a few questions myself. So the first question is from Sam Wilton asking, so saying that the percentage word plot for personal attacks is a very interesting plot. And the question is, there is a reason for the sharp spike at around the 750 revisions on the cumulative percentage of attacks by number of the revisions, like basically bimodal distribution. What are our thoughts against expanding the distinction of Nithum was elaborated?
Yeah, so I think, Nithum, do you want to take I think they're separate questions, but Nithum has a great answer for that spike.
Oh yeah, so the spike, if you want, I don't know if it's a lot of effort to throw that slide back up, just so that people can see the spike. But the spike actually represents one user, one specific user who is definitely a kind of troll. So this user has written 707 revisions on Wikipedia, of which 440 were found to be attacks. So 66% of everything they've written is an attack. So that vertical line you see in the middle of the graph there represents one very trolly user who's written, who has an attack fraction of 66%. Yeah.
Another kind of related question, if I can interject. So I think it's very interesting the point you made about sock puppets, right? And it sounds like the problem is that we have no understanding of the actual distribution of accounts that have multiple identities. So I'm wondering if this kind of research suggests we should be doing sock identification as a precondition for understanding better these two populations. In other words, how do we characterize this the younger part of the plot, or these actual sock puppets? How many we have? Could some of them actually be not sock puppet accounts? But curious about your thoughts.
Yeah, I mean, so one thing you could imagine is if you had the Oracle model, the perfect model, and you see an account that opens up, and the first thing that this account does is it posts the user talk page comment that is an instant harassment or personal attacks. Right? That would be sort of a very clear signal that that this is a sock puppet. Given that the model has flaws, right? What you get this soft score. You might want to flag it, have people sort of maybe look at, oh, what's this account about? And as you see more and more data, you may be able to probably very quickly characterize this account. Once you see 4 or 5 attacks coming from this account with in a short time span with very little other activity, that would be sort of one detection method. But one thing that's hard is, how do you get ground truth labels for this? Again, it'd be something that we could try to crowdsource.
The other thing I would say is these tools are most powerful when sort of coupled with human administrators, and so, as Ellery was saying, this could very quickly detect people who are potentially sock puppets and have an administrator follow them much more closely, which would reduce the work for the administrator because it would tell them who they might want to focus on.
I don't think we have other questions from the channel. Any questions from the audience? No, and if not, I'm gonna yes.
A quick question. So I'm assuming that we're not the only ones interested in modeling that kind of personal attacks. So do you know of other websites or other organizations that have done similar work, and how does that compare with what you've done?
Sure. So there's actually, some of you may know Nithum Thain. He has done sort of like on Wiki actually he has sort of a large literature review of all the different ways that different companies who have websites or online games are sort of trying to tackle this issue. So that would be a resource to look at that we can maybe append to like a resources link. Actually, we have a project page that links to all these resources as well. There's been recently, the last 2 years at a computer science conference called Yahoo Research has been sort of publishing papers on sort of specifically how they model personal attacks and the reason why we just use n-gram features, for example, is because they try 1,000,001 different things, and the n-gram features turn out to be sort of like the most powerful single feature set, and just using those features gives you sort of almost all the performance from using all the features that they tried. That's some recent work. There was also, I forget the name of the game, but sort of one of the things that inspired this research for us was some activity on Wikimedia L, where people were, I think it was Denny, sort of showcasing, was it Riot Games?
Riot Games has done a lot of work on this. Yeah, Riot Games, who are the makers of League of Legends, have done a lot of research on personal attacks and have had a lot of success in behavioral change within their community, actually.
I have one final comment before we move on to Daisy presentation. Actually, a comment and also a question. The first comment is that really announcing that we're working on releasing a dataset. So as you said, we have prepared as part of the precondition for this project an annotated dataset. This hasn't been released yet, but I think one of the plans for next steps is going to be to just generate a clean data set with the scores generated by the model. And I think it's going to be very motivating for other researchers to participate and interact with this research.
And so there'll be 2 data sets, right? There'll be the annotated data, so the comments that we sent through Crowdflower, and then each of the 10 scores. And then what we'll also release is the sort of complete history of talk page diffs. We're actually focusing on user and article namespaces, and sort of we'll have the raw diff, the sort of like cleaned up diff, and then also the model scores.
Fantastic. And the other quick question, something that came up during our conversation, is about the population of coders, right? So I think you mentioned that obviously we have issues around detecting more subtle forms of attacks, and also we discussed how different segments of the population may have different tolerance for personal attacks and harassment. So I was curious if you could say something about the next steps, how you guys are considering potentially addressing that problem.
Yeah, so one of the most interesting things that we would like to do is to basically, Aaron Halfacker has a system called Wikilabels, which is a way to sort of get Wikipedians involved in sort of labeling data, like any form of data, but in our case we'd be interested in labeling diffs. So it would be really interesting. So first of all, to see how Wikipedians differ from Crowdflower crowd, just because of it's a different demographic, but they also participate in the projects, and that you mentioned, there may be different norms around communicating that aren't shared sort of in the population at large. That being said, Nithum will know more about this, but there are ways to, for example, have the data labeled by people whose primary language is English and so forth. But,
yeah, there's certainly, we are working on ways of getting more nuanced attacks to be recognized in the data. And as Ellery says, it is working with other groups of people and other crowdsourcing resources to get that initial set of high-quality data. And we can sort of leverage the work we've already done because we don't now have to look at the whole ocean to find things. We can look at things that are near the margin for our model, and hopefully those will be the ones with more subtle forms of attack. The other question you asked was on a degree. And that's something that we're working on. So we're trying to calibrate our model so that the scores that they output represent something about the degree of attack, so that the higher scores correlate more closely to the most vicious attacks, and the medium scores correlate more closely to sort of the more benign attacks, if we can call them that. That's not something that we're there with yet, but it's certainly an aspiration, and that would be something that could allow people who have different thresholds or different tolerances to set their own, or at least start playing with it.
And another thing that we're doing is, I mentioned that people can get warned or blocked for personal attacks. Currently, both of the mechanisms in which that happen don't require the person who is issuing the warning or the block to cite the actual instance of the attack. That is why sort of when we create this block user data set, we have to sort of look at everything that they've said, or we look at sort of the 10 things they said before the block actually happened, which is sort of an imperfect proxy. So it'd be really amazing if there was like a strong encouragement to sort of cite the revision IDs that sort of brought about a warning or a block. So there, we're talking to Matt Flash, and he's sort of volunteered to update the no personal attack warning templates, so that's optional, to add a revision. Of course, it would be great if there's sort of this, people are really excited about sort of adding the citations, because currently it's optional, but that would be a way to sort of continuously get labels from Wikipedians. And then also in the block interface that administrators use, currently you can sort of select the reason if you don't cite the actual revision where the attack was inserted. And I think that would be better for sort of like transparency, but specifically for us it would be really exciting because we would get label data. So that's something that I think we're working with community tech, or I don't know if you in the room have suggestions for a good approach for that, but so far we haven't had much luck with that.
For adding the specific edit in the warning template, maybe that could be built into some of the anti-vandalism tools that people use. Because a lot of those templates, the warning templates, are added by patrollers and vandal fighters with a click of a button through anti-vandalism tools.
Okay. So
maybe a lot easier to get people to add the ID of the edit if they don't have to do anything, if that's just included into that one-click warning button.
Oh, because, okay, they see in the supervisions like, oh, for this I'm issuing the warning, and you could just make the gadget or whatever include the diff works. Like, yeah, that would be great. Yeah.
Fantastic. I think we need to move forward to the next presentation. Let's give a round of applause to our presenters. And next up is Liz Chen from the Design Research Team, presenting on research on the wikipedia.org page.
All right. Share. Oh, here we go. I've never actually done this on my computer. Here we go. Okay, so I'm just Daisy. I'm on the design research team at Wikimedia, and I did some work for the discovery vertical, specifically the wikipedia.org portal, and the new dropdown for languages by article count.
Can you present?
Oh.
I think it's not presenting yet.
Shows as full screen on my, oh goodness, what is this?
I'm not sure you actually, I've never been able to actually get it to work on Hangouts.
Oh, really?
Oh, yeah.
Okay.
All right.
It just doesn't go into present view.
Oh, yeah, look at that. It looks like the button is delete, but...
Yeah.
Sorry, you see a separate screen. No big deal. It's
Okay. All right. So it might be a little bit smaller. Okay. So here are some research questions that you can just kind of read through. I'd like to give a little bit of background as to why this study was conducted. So there are two main things. So the first thing that the discovery team was looking at was why people go to wikipedia.org, and the majority of them kind of just drop off. So they don't do anything on page, they don't click links, they don't search. And the second thing was is there anything on the wikipedia.org page itself that could be improved? And one thing that Deb, the product manager on the discovery team, looked at was this kind of revamping of the language list by article count dropdown. And I can kind of show you the difference real quick. So this is the portal page as it is right now. It's live. Scroll down and kind of see this long list of languages. And the revamped version is kind of this dropdown that we're talking about here. All right, just go back here. So just going to go through the research questions real quick. So the first part is about the portal page itself. So how do users get to the portal page, and how often do they go there? And once they get there, what do they do? And also whether they're aware of that section. Once you scroll past all the languages, do they ever see the section with all the sister project links? And then the second part is a little bit about search behaviors in general, and also search behaviors using Wikisearch. So how and why do users look for information on the internet in general? What devices do they use, browsers, other methods? What are user impressions and experiences of using Wikisearch generally? And also when and what do they search for when they use Wikisearch? And the last part is the language list by article count dropdown. So what do they think of it? So you may be asking, why so many questions when there are really only two? What do they think about the dropdown? And also, why do people suddenly drop off when they get to wikipedia.org? And I talked to Deb about this, and we kind of figured that this would be a really great way to kind of get some contextual understanding of what people do when they search on the internet for information. And also their interactions with wikipedia.org, search on Wikipedia, and just kind of what they do around search behaviors. So what we did was we created a protocol that covered all of these things. And so it's a combination of kind of the evaluative questions, which are, what do people really think about this new way of looking at the language list? And also, how do people get to wikipedia.org, and why do they drop off? So all these other questions that we came up with were to kind of establish some more contextual understanding, and also effectively create a scenario where the user can kind of just naturally show their search behaviors instead of being asked pointed questions about certain new features or things like that. So getting more natural responses. So we ended up running 5 recorded Hangouts on Air with participants that we got from a survey. So Deb actually ran a survey on wikipedia.org asking people to tell us how they got there. So some of the answers were, oh, I have it as a bookmark, or I have it set as my homepage, or I just type it into my URL. And we got some answers from that, and we also asked people to provide their contact information if they'd like to be asked kind of about their experiences on Wikipedia. And we were able to talk to 5 of these people. And some basic information about these people are, there were 4 men and 1 woman. All of them said, I use Wikipedia as my primary destination for learning. So when I search online, I look for Wikipedia links first in my search results. 2 people self-designated as rabbit hole readers. There were 2 former editors. One was more casual, one was more active. He's created pages before, but they kind of cited, time and also not having that much to add to most Wikipedia pages they come across as reasons that they don't really actively edit anymore. There are also 2 current students. One is a med student and one is a math PhD, if I remember correctly. And one is primarily a mobile user, and he also uses Wikipedia Zero primarily. He's from Nepal, I believe. And the other 2 cell rows there a little bit about what primary devices they use and also what browsers they use. So we're going to jump into the findings. The first section is about the portal page. So first, how do people get there? So 2 individuals we found actually type wikipedia.org into their URL bar. And that's just how they get there. One person doesn't even go to en.wiki because it's too much work. They just type in wikipedia.org and just go directly there. One has it set as their homepage, and one has it set as their bookmark. And one just does a little bit of both typing it in the URL and using it as a bookmark. So this is actually really interesting because the survey that Deb ran actually kind of correlates a little bit to these numbers, even though this is a really small sample size. So that I thought that was kind of interesting. And this shows a little bit about kind of these 5 users' progressions through the portal page. So a little bit about how they access it, how often they access it, and then what they typically do once they get there. So as you can see, 4 people actually use it pretty often and access the page pretty often, and most of the people end up searching if they do go there and do something on the page. All right, and in terms of how many people actually knew, there were further links on the bottom of the portal page. 4 out of 5 of them knew about the sister links, but they don't actively involve those links as part of what they do once they get to the portal page. So as you can see, some of the quotes up there, you know, I haven't clicked on these links before, but I know that they're there. A few of them have clicked on them before, but only to try and figure out what they were about. And one person didn't even know that these links down here existed. Okay. And a little bit about search and on Wikisearch. So as you all probably know, individuals just go to Wikipedia to learn about background information on things, research topics, whether it's for professional use or just kind of figuring out, you know, what actress was someone in a movie or something like that. All 5 users use search engines to get to Wikipedia. And a lot of them add wiki to the end of queries when they want Wikipedia-specific results. And so to get into Wikipedia more specifically now, do they ever use the search function on Wikipedia? And actually all 5 of the participants that I spoke to did. One actually uses it 80% of the time. So this is the person who types in wikipedia.org into the URL and just, I guess 80% of the time, she'll actually go into the search bar on that page and type in query. 3 of the participants have used it, but don't use it often, and 1 very rarely. So this is actually the person who is primarily using their phone, using the NSL network. And so here's some quotes about how people feel about Wikisearch. So some of these are, you know, kind of expected. It's okay. Sometimes if I get it right, the results are good. If I get it wrong, so if it's misspelled or recalled incorrectly, the results aren't always helpful. People know not to search for longer queries or kind of actual questions in Wikipedia because, as this one person says, I get garbage back. So it's kind of an understood thing that you can't search longer queries using Wikipedia. It has to be very specific, very pointed, and usually you have to spell it correctly. However, one participant, this is actually the one in Nepal using NSL, he said that, oh, I used my friend's iPad recently, and I noticed that the autocorrect was getting better on the app. I don't think this is actually reflected on the browser yet, but that is a good step forward. And when and the what. So when do people use Wikisearch, and how do they use it? Participants usually use Wikisearch when it is suiting a specific scenario or use case. So a lot of people say, you know, I'll use Wikipedia when so most people say, you know, I'm on my browser, and I'll usually use the URL bar to search for something, and I'll use whatever my pre-selected search thing. I can't. So Google or Bing or whatever they set as their default search will come up with search results. So only the specific use case that one person said was, if I open Chrome and I already have something in mind that I want to search, and since I have it set as my home page, if I already have something in mind that I want to search, I'll just go ahead and use that. And again, participants said that, I want to really make sure that I have something specific in mind when I'm using Wikisearch. Otherwise, I probably won't get good information. One more user also said that for professional search, like professional work-related searches, sometimes he might not go to Wikipedia, even if it is a specific term, because he comes across a lot of technical terms, and in his experience, sometimes they're kind of stubs, or they're not accurate enough, and so he'll use Google or Bing or something like that instead of Wikisearch. So the last thing is the language list by article count dropdown. So we kind of snuck the question in there about showing them these 2 pages and kind of doing it at different, just kind of showing them at different orders. So sometimes I would show this this live version first, and sometimes I would show this new version first. And I didn't really get a sense that people had an understanding of which one was actually the actual page. But I just wanted to make sure that it wasn't, a scenario where I would say, okay, this is the version we have now, and this is the new version that we're considering. Because in my experience, a lot of people kind of automatically tend to say, oh, the new version is better just because. But here are some of the responses that we got. There's a little screenshot there of the 2 different versions. So 4 of the 5 participants mentioned that there was some preference for the prototype version. So the main pluses with the prototype version were that there's a lot less visual clutter, and you can actually see the sister project links instead of having to scroll through all of those text links of the languages. And one participant didn't really mention preferring it or preferring this current live version. And we also got some additional comments from participants. Even though there was a lot of positivity about how it looks visually now in this prototype version, a lot of people still felt like it's still kind of busy. The new version is still kind of busy. Others felt that, it doesn't really make a difference to me. It looks pretty similar to the current page, and there's still a lot of text. Others said that it's great that I'm getting to see all this stuff, but I don't know how often I'd actually click on it. And one person actually mentioned, well, I wouldn't use this very often anyway, but before I had a list of languages that I could randomly click on. It was kind of fun. But now I have to click one more time because of the dropdown. And there were two people who actually mentioned specific things that we need to keep in mind for this new dropdown. So the first thing is that when you click this, it kind of, you can see the dropdown is kind of hovering over the rest of the page and covering up content. So one person mentioned that perhaps we could look into kind of UI best practices and see if it's something where we can push down the background content past this drop-down window. And another mentioned that the drop-down could be finicky on phones. So those are 2 things that we are keeping in mind to keep track of. So in summary, I'm just kind of putting all the research questions on the left and the general answers on the right, so you can kind of get a little sense of what the answers were to the questions. So how do people get to the page, and how often do they go there? The answer is that the majority of the participants type wikipedia.org into the URL bar, and they actually access it pretty often. And most people will use the search bar on the portal page once they arrive at that page. And most are aware that there are further links past the language links on the portal page right now, but most don't do anything with it. In terms of search, people search to learn background information on topics on Wikipedia. And generally, Wiki search has improved in terms of kind of autocorrecting misspelled words in searches, but it definitely doesn't come close to the power of Google search. And that specific search terms usually yield good results, but they know better than to search for longer queries. And the last thing about the language dropdown is that most think that it offers visual improvement, And at the same time, there's still some concerns about it. So my recommendations to the discovery team were to promote to production that new language by article count dropdown. Because most of the reaction is positive and no one is actively fighting it, there is just there are some small concerns that we can address, and there's just some apathy, which is, it's okay. So those two things that I mentioned before, we want to confirm that the dropdown doesn't negatively affect awareness of other page content that it's covering right now. So maybe we want to look into pushing content down a little bit. And the second thing is to make sure to test it when it's live on mobile devices. In terms of search, there are plans right now on Discovery to optimize search in various ways. Dan, Gary could probably speak a little bit more to that. And also, generally, kind of determine whether it makes sense to try to support more types of queries like Google or Bing do. And for reference, you can go to, there's an RFC page right now about the dropdown and the page layout. That's the first link. You can read more about plans around the portal page at the second link. You can contact me if you have any questions about this specific research. And Deb Tankersley is the PM product manager for the portal page, so you can email her if you have any questions about that as well. The survey that I mentioned about the wikipedia.org portal page is also something that you can reach out to Deb about. And that is all.
Thank you, Daisy. Any questions from IRC or the room? I don't see anything from IRC. I'm going to leave a few more seconds to see if someone has something to ask. Yes?
So thank you, first of all. And so I had a question about the languages. So I'm assuming that all the people that you talked to were English speakers, if not native, then at least in a second language. So the new design basically places the emphasis on sister projects instead of other language editions. So have you considered talking to people who were not trying to get to the English Wikipedia and see how much difficulty is with the new design? And I also know that the Discovery team has been working or has published a new version with auto detection of the user's browser's language. So which was that already enabled when you tested this?
I'm not aware of whether the you said it was like auto detecting languages.
Yeah, like the top languages, those that are ordered differently, depending on the language of your browser.
I'm actually not sure. Maybe Deb can speak to that.
Yep, I can definitely speak to that. So the language detection we did launch, I believe, in early June. I can't remember the exact date. So when Daisy was actually talking to all these participants, that was already in effect. So if they had their browser set for something other than English, which all of them did as far as I know, their preferred browser language would have shown up at the top, link on the very top left around the globe, and we would have seen that in play.
Okay, yeah, so basically, with both those changes, you were trying to move the choice of language from a natural decision by the user with basically all the options to something that is more automated, when they can focus on the search and perhaps on the sister projects. Is that correct?
That is correct, because we want to make it easier, because some people have, those languages are not in the top 10, so they're not going to be able to easily find it. So that's why we want to do the language detection in order to show, those language links. And some of our people that we found from their testing that we did for the language links, as far as resorting them based on browser preference, there was actually, I think, almost 2% of people had 2 or more languages set in their browser preferences. So we do actually have quite a few people that are pretty savvy with that. But yes, most people are English because that's there's a lot of different reasons of why the browsers are generally set to English. Some people just don't know how to change them. A lot of people use it in, public spaces, libraries, that type of thing, that maybe they can't change those preferences. But yeah, it's a more of, we wanted to make the page a little bit cleaner, easier to use, easier to find things. And for the anecdotal, notice we found is that a lot of people, didn't know the footer were there because they just never scrolled down that far. And so we wanted to make it much easier to use. It's mobile friendly. It's something that we're not hiding anything, but we want to bring the emphasis to the search bar because that's generally what people come there for.
And I would add that even though I think 3 out of the 5 participants I spoke to were native English speakers, going to en.wiki.org was not kind of like a typical workflow. And for the other 2 who weren't native English speakers, they actually indicated that they went to en.wiki.org from the portal page more often than the other 3. And I also noted that none of them, even the ones who said, I do click on the language links sometimes, that they were mostly kind of for fun. It wasn't a specific targeted, like, I want to go to this language site. So it didn't raise enough of a red flag for me to say, we should really keep these text links open at all times instead of creating this extra step to get to them.
Right, and something I wanted to add on about the survey of how we got these participants. So we ran 2 Qualtrics surveys on the portal. The first one ran for about 2 weeks, and then the second one ran for a week. We got, I think, a total between the 2 surveys, I think it was about 1,200 people that responded to say, because the question at the end we had was, would you be willing to talk with us further? And so a lot of people gave us their name and an email address, and then we had Daisy and Samantha reach out to these people. One of the interesting things I thought were that a lot of people didn't understand how we got their email. It's like, well, you responded to a survey. And they're like, oh, I don't remember that. And so the people who agreed, who responded back to those requests for contact email, some of them, didn't want to sign the waiver, didn't really necessarily want to talk to us. They weren't quite sure how we got their name and such. So unfortunately, we didn't have a lot of people that were willing to talk to us about this. So one of the comments I had previously is why didn't we call it to get other than English speakers? And unfortunately, we just didn't get that on our survey. So we tried to do the best that we could with the respondents that we had.
One more question here.
Yeah. So my question is, I was surprised to see that so many people use the portal search bar. Do you think that's related to the fact that these are avid Wikipedia readers, that they read it almost all the time? Is that?
I didn't get a sense of that. I think I was definitely surprised to see that pretty much all of them have used the portal search before, except for that one person from Nepal. But I didn't really get a sense that, they're really avid, like, Wikipedia, like, only readers. I think it's from the way that they described searching in general and also how they searched on Wiki, it seemed like a pretty representative way that most people would use search in Wikipedia. I think that one person described it very well. He's like, if I'm just going to, if I just open my browser, the first thing I usually would want to do is go to like Facebook or my email or something like that. And if I want to search something after that, I'll just search in my URL bar. But if I open my browser right away and my portal page is my home page and I want to search something off top, then he'll just use that. I think that is, I think that's pretty natural. No one else specifically said, I only go to wikipedia.org to search. But it was just kind of more part of their search workflow than I expected, definitely.
Yeah.
But it's not like I don't think it's necessarily a misrepresentative group.
I have another question on IRC in response to the question of the search engine versus wiki search.
Oh.
And the particular question is, so the these participants also say they use a search engine and they add wiki to their query. They said they use wiki search for exact terms. Does it mean that we prefer the portal page over Google to very specific words or technical terms?
So I don't know if I can say prefer is the right word. I think it depends on the use case. So as I mentioned, some people, if they're searching for something professional and they've had experience searching for technical terms related to their work that they haven't gotten good results from, even if it is a specific technical term, they still might not use Wikipedia in the future, and they'll use Google instead. Definitely, scenarios where participant 3, she said, I had this query yesterday and I wanted to find out the name of this game, but there's no way I would ever use wiki search because I want to kind of put hints about the game that I know because I don't know the name of the game. Only if I know the name of something would I search for it. Another participant said, for fun kind of pop culture things, I'll definitely use Wikipedia because those things, those pages are usually full of information. They're very detailed. And the med student said, most kind of more general scientific things he'll search for background information, but specific, very, very specific scientific terms, he will be a lot more wary of searching for Wikipedia. So.
Got it. Yeah. And the follow-up question here, I don't know if we want to do this online or offline, but it's basically what gets people to move to the portal page for a query. And I wanted to use it also to segue into a related question I have. So it sounds like at a high level, from what you're saying, from what I'm hearing from that this is basically a place that's been used for years as a hacky way of getting into a landing page for a search, right? So it sounds like this is very much ingrained now in the way in which people use it, if they use it. And verse functionality is pretty much something they don't use or they're not aware of. It's an overall sizable but relatively small fraction of the total traffic we get, including search traffic. We are Wikipedia, so that's something to keep in mind as a context. My question, I guess, is mostly for that from a product perspective, is if this is a primary use case, should we think of stripping down as much as possible from the page so that we really get to the bare bone of what people are using it for and try and teach that use? Or are you guys thinking of basically expanding these to other uses? I'm curious about the tension between simplicity as informed by the current use base, which is a very specific use base, versus expanding it to drawing potentially new readers.
Well, yes and no for the whole thing. What I see our users, especially the readers, is they use Google and Wikipedia hand in hand. They'll go to Google, they'll go to Bing, they'll use whatever, they'll find out more, they'll find links to the articles of what they want to read. They found that, unfortunately, searching directly on Wikipedia, whether it's ENWiki or the portal page, they're not always getting exactly what they want. So they've gotten accustomed, I believe, to using Google, Bing, some of their search engine, to then get that search better for them to find the articles that they're trying to read, and then use it after that. They know Wikipedia is a great source. They know they want to go there. They just don't necessarily know or have had a lot of really good experiences in the past. And so I think it's just kind of a natural outcome at this point. On the search side, we are doing a ton of things to make things better. We've actually got a new TextCat thing rolling out in a couple of weeks that if you mistakenly put in Russian and you're actually on ENWiki, we're going to try and show you some Russian results. So we're doing a lot of good things that we can do to improve search. We realize that we're about 7 people compared to Google's thousands of people working on search every day. So I think that our user base understands this. They don't expect us to be perfect. They want us to be better. They want us to get better all the time. But they also realize that they can get to the article or articles that they want to read by using Google and then going directly in. Does that help to understand? Well, let me. Sorry, one more step. So I don't think we need to strip down the portal page to bare bones. I think we have a lot of people that still go to the portal to find out the stats because they're very passionate contributors and they want to make sure that their preferred language wiki does move up in the stats. And we have that question all the time. So we actually update the stats right now on the page about every 2 weeks. One of the questions that we've had from the users of the smaller wikis is that, is this new drop-down going to hide things? Well, they're not going to hide things because you would have had to scroll down, 3 pages worth to get to your language anyway, because it just doesn't have that many articles. It has 500 articles or it has 1,000 articles. But we wanted to make it much cleaner and much easier to use and focused on the search bar, because that's generally where they're coming from, is for those readers then who land on the portal page, not necessarily the passionate contributors. I mean, it's both, obviously, that we want to reach out to, but we understand that most of the people that come to the page are most likely the casual readers.
Thank you.
I hope that answered your question.
Any other questions? I don't see anything else on IRC from the audience. If not, round of applause. Thank you. And just want to check if there are any final outstanding question on book presentations before wrapping this up. Also to reiterate that, as we said, both reports are on Meta, so a very obvious way of engaging on this research is to go to the link to our projects and comment on pages. I think we're looking, I say specifically on the harassment detection project to try and get perspectives from different communities, from people who are moderating or processing these issues. And so it's really critical that we get as much participation as possible. Thank you for participating, and see you all in a month from now for the next edition in August.
Awesome.
Thank you.
Thanks.